So Michael Gale, yeah, more caffeine. He actually is going to talk about himself, which is probably a better job than I would do, right?
Just for about 40 minutes.
Just for warm welcome for our next speaker.
All right, thanks everyone for coming today for the OpenStack security talk. A little word of warning, if I get really nervous, I talk really fast. If I get really excited, I also talk really, really fast. So I will try and stay in the middle. This morning when I got up, this is how I felt. Yeah, worst idea ever. Hey, do you want to give a talk? I said, sure. And they say, you're like, what was I thinking? Maybe I can call in sick. Who am I? According to my LinkedIn page, I enjoy writing software and designing infrastructure helps other people excel at their jobs. So I enjoy doing back-end and middleware work, mostly with code or infrastructure. I have a strong passion for Python programming language, so I try and do a lot of work in that space as well. I've been at Payson since 2005. Since then, I've been in multiple roles. I've been a Linux network admin, looking after Linux servers, patches, upgrades, stuff like that. I helped create their site reliability team, which is like SRE or equivalent. As an initial member of that team, when it started out, I attempted to manage that team for a while, at which point I realized functional management was definitely not for me. I helped bring a lot of firsts at Payson, so I helped them bring in configuration management, tools like CF Engine, Puppet, Ansible, things like that. I moved us into proper package management for our in-house apps that we build, and adding package management tools, things like Red Hat, Spacewalk, or Satellite Service, stuff like that back in the day. I then moved into the architecture space. My official title there for a while was IT Architect of Infrastructure and Communications. It sounds really fancy. I helped a lot with our cloud adoption and moving our infrastructure as a service platform forward. We brought in AWS originally to help out with our dev, test, QA capacity because we didn't have a lot of capacity in-house to meet all the needs of our customers. And then we were looking at using AWS for our DR space. Now we're using OpenStack to provide that infrastructure as a service layer to our customers, giving them AWS-like functionality. Standard disclaimer slide, pretty much saying you can't blame Payson or the OpenStack Foundation for all the stuff I made up and put in these slides. Overview. So what we're going to cover today. So ideally a brief OpenStack overview, because maybe not everyone is familiar with it. The OpenStack security project, an introduction into network security, and then a standard HTTP encryption setups. Sorry. The other thing we'll probably want to talk about today is we're going to cover security from the responsibility of the provider. So in the OpenStack space, there's kind of, as you can see here, there's the customer responsibility and provider responsibility, and it's important that you keep those two things separate, especially in very large organizations, mostly because different departments have different responsibilities, and they should look after different layers. When you put them all in one group, let's, for example, say you decided that your DevOps team would handle all the stack, you end up creating that bottleneck, and then you end up building a solution that is very cloud-specific dependent. You don't end up with a cloud-agnostic solution, which is probably what you want in the long term. So who here has OpenStack running in a lab? Anybody? Anyone want to admit to that? All right, we got one person. Two people. So let's go with then no one has OpenStack running in production. It's probably a safe assessment. Who here has no idea what OpenStack is? No one wants to admit that either. All right, we'll go with one person. All right, so what is OpenStack? Here's the standard Wikipedia article. There's lots of stuff there. I like to describe OpenStack as an umbrella framework that brings together multiple components. It provides a nice infrastructure as a service platform. And this last part I'll read off because, well, I don't want to mess it up. So it provides a flexible framework for an open cloud solution. It is not a universal cloud solution, which is probably a very important thing to consider. Lots of people look at OpenStack and they think, hey, this is great, everything's free. I'm going to take this and deploy it. based on your business needs, you may not be successful when you go down that road. You have to make sure that OpenStack is really designed for what your business needs are. So, because it considers multiple software projects, it allows the consumer to implement the required features and functionalities that is needed by the business in a manner that best matches the underlying business needs. So, pretty much, if you need a cloud-based technology, or if you don't need a cloud-based technology, maybe OpenStack's not right for you. A few years back, there was actually a really good article from a Google Cloud engineer. And their kind of rule of thumb was, hey, if you only have like 50 VMs or less, deploying an entire cloud stack is probably not the best move for you. You can stick with VMware, stick with KVM. There's lots of alternatives out there. If you need to do 50 or maybe 100 to 200, there's other options out there. Once you start getting into 200, 250 plus space for number of VMs, then maybe it's time you start looking at infrastructure as service platforms and implementing a cloud-like solution. So this infographic has been at most OpenStack conferences I've attended over the years. It makes OpenStack look amazingly and simple. On the left, we have a compute, a square box. That looks awesome. You've got some networking there in the middle. That looks great. And storage at the end. That looks pretty good. And you have a dashboard that allows you to manage this platform. And security is probably in there somewhere. Here's a picture of a standard OpenStack dashboard. So when you log into the dashboard, I can see my capacity and usage here. You got number of instances. I'm in yellow because I'm almost out. I only have 50 left. RAM, CPU, floating IP addresses, that type of information. On the left-hand side, you can see here you can control instances, you have volumes, there's images, access and security. That's where when you're in your cloud space, you can assign firewall rules and stuff like that to your instances. And then there's the networking part there near the bottom for software-defined networking. Still looks pretty good. Then you have the 6 core services that are in OpenStack. There's Nova. Nova takes care of all of your compute resources, whether your underlying functionality is KVM, you've attempted to use ESX, Hyper-V, whatever that. Nova is what looks after all of your compute infrastructure for you. Neutron does all of your software-defined networking. Swift is your object store. Best relation would be like Amazon's S3. You can store objects in there. It's all available over a REST interface. On the bottom here left, we have Cinder. That's after your block storage. So that could be anything from LVM at the back end to a NetApp to SolidFire. There's tons of pluggable options you can use in that space. Next is Keystone. That takes care of your identity management. So all of your users, groups, what roles they have, what projects they can access, that type of information. One thing that catches some people off guard so OpenStack is designed from a multi-tenant space from the ground up. So the admin user, when you log into your cloud, has access to look at the infrastructure layer from a capacity point of view, but it actually, by default, can't really go into every project space and touch instances. So some people are thinking, well, great, I'll just create an admin user, he can log in, he can touch all my tenants. Now, if you're offering a public cloud, you probably want that effect. If you're doing a private cloud inside your company, it'll probably be really frustrating for your DevOps or IT guys because they can't go into every single project and poke around and do things. So it's something to keep in mind. Glance is your image service. So inside your OpenStack environment, you have multiple trusted images. It's like your Amazon AMIs. So you have maybe you have a Red Hat one, and maybe Ubuntu, CentOS, that type of stuff. The Glance service is responsible for providing all of those images and allowing you to boot from them. So the 6 core ones are considered very mature inside the OpenStack space, and they all have at least 4+ years in age. You can see they all have this nice little green circles. If you go to that link, you can get all the updates on all the different OpenStack projects. All the different OpenStack projects. Optional services. So this gets into a little bit of crazy space. So there's all these optional services. There's currently 13. The ages range from 1 to 4 years. Most of them are not considered mature. So as you can see, the green ones, which is Ceilometer, which is all your telemetry, and the other one should be Horizon, which is your dashboard. Also not Heat, your orchestration is the green one, and Horizon is your other green one. So those ones come pretty standard. Those are considered mature. Lots of people use them out there. The rest of them, their documentation, support, and deployment can kind of be all over the place. It all depends on how mature the product is. So excluding those top 3 there, which are Horizon, Ceilometer, and Heat, I would stay away from the rest of them. They usually don't come packaged with vendor tools, and if you want to use them, you normally are having to do all the support, all the packaging, the deployment, and all the implementation yourself, which is, depending on how big your DevOps group is or your IT group, you probably don't want to take that on. So here is a potential logical architecture diagram of what your OpenStack environment could look like. So we talked about those 6 core services in the beginning, and they all kind of play into the space, which is earlier when I laughed because I said security is probably in there somewhere. So if we go from left to right here, so you have the Swift box is on the far left, you have the Glance API, Nova's in the middle, then Cinder, and then Neutron on the right. Now, all the black lines on this diagram, those black arrows, they represent connections coming in from your public domain. So if you had a public cloud, this is everybody on the internet. If you had an internal private cloud that's only for your company, this would be everyone on your LAN. All your customers, internal inside the organization, they're coming into your OpenStack space. All the red connections are what is on your management or your control plane. So inside the other security domain, which is your management control plane, that's all of your internal API interactions. So the only thing that this diagram really doesn't show is that normally there is a load balancer handling all the incoming API requests, because everything in here is obviously redundant. So, into the security part of it. So if you go to security.openstack.org, you can see there's got things like recent security advisories. The last one was on March 8th, had to do with the Nova vulnerability. You can look how to report issues, and they also have security tool development. There are currently 2 tools in development in the space. One is called Bandit. It is a OpenStack security linter project written in Python. So is everyone here familiar with what a linter does? All right, sweet. So when you write software, whether any language, a lot of times you run a linter program against your source code. So standard ones will look for potential buffer overflows, unallocated variables, stuff like that. So they'll go in there and look for potential errors. What Bandit does is it analyzes the code looking for security flaws or security errors that they have in the code. The other project they're currently working on is called Anchor. I'll read the definition of Anchor because it's pretty new, it's not out there yet, and it is, well, it's kind of confusing. So Anchor is a lightweight open source public key infrastructure which uses automated provisioning for short-term certificates to enable cryptography, trust, and OpenStack services. So instead of having to use username and passwords everywhere, it's trying to push out PKI to the services. A lot of these certificates are only valid for, I think it's 12 to 24 hours, but that project is still very new and has not been deployed yet. Here's the Wikipedia example of OpenStack security project. Pretty much what it says is there used to be 2 groups. There used to be an OpenStack security group and the vulnerability management team, and they were separate. So what they did is they just created the OpenStack security project, put those 2 groups together. Here's a pretty infographic that kind of goes over what that group does now. So in the top right, in pink for some reason, is the vulnerability management team. And then you guys love the things across the bottom. So they look after like developer guidance, security notes, security guidance, threat analysis. You have Bandit and Anchor there that we just kind of went over. 2 new ones that I believe are in development, but there's no project documentation for them yet, is the auditing and tracking and the secure API testing. So the vulnerability management team. They take care of actually creating all the patches for fixing vulnerabilities in the OpenStack release. But they only do that for the security supported projects, which currently means it's only the core 6 plus Heat, Trove, and Sahara. So if you're using one of those other 13 supported projects, you're kind of on your own in regards to either A, discovering any security vulnerabilities, or B, if any are found, having to fix them and patch them yourself. So a lot of people end up sticking with the core 6 just for reasons like this. The other thing is they only fix and patch the either current, like the current stable release or the previous release. They don't go any further back. And OpenStack releases twice a year, normally every 6 months. So depending on what your upgrade speed is and who you get your OpenStack product from, you really have to figure out some way to manage that security lifecycle. So on that topic, here's the OpenStack releases. So we have, let me pronounce this, Mitaka, which got released here in April. Liberty was released in October 2015. And Kilo was released April 30th, 2015. So let's go with an example. Let's assume that your provider takes about 3 months to package and distribute their OpenStack product, which is actually pretty fast from most providers' point of view when you talk to them. IBM's claim to fame for their OpenStack product is 3 months. So then let's assume that you have the ability to upgrade within a month your OpenStack environment, which is probably pretty fast depending on what else your organization has on the go and how big your environment is. So let's assume, going with Kilo, that it was released in April 2015. The provider uses May, June, July, and gives you a release in August. So you install the release in August, you're great. Takes you the rest of August to upgrade. You now have 9 months until that version is EOL or EOL from a security point of view. Meaning that hopefully your provider will come out with their next OpenStack release, and you can upgrade quickly within that time. The other thing is not all providers have the same upgrade lifecycle. So for one example is there's a current OpenStack product on the market where they give you the Kilo release. They decided from a company perspective to skip over Liberty, and they're going to have their Mitaka release available sometime June or July. Which means, well, if you're an OpenStack customer, okay, well, I have my Kilo release I bought from you that I paid a lot of money for. Its security is ended here in, what do we say, April? And then now I have May, June, July. So if the company hits their target date, great. You're only 3 months without any security patches, and assuming there's no zero-day vulnerabilities, that could be great. Or if the company misses their target, maybe you're vulnerable for a lot longer. So in picking OpenStack products, it's very important to figure out what their upgrade, release cycle, and patch management cycle is. Downstream stakeholders. Does everyone know what an embargo period is? No, I'll give a quick example. So the voluntary embargo period inside the OpenStack space is 3 to 5 business days. So let's assume that you have a project and you have downstream redistributors. So if you're the OpenStack space, you are the project. Your downstream distributors is people like Canonical, Red Hat, VMware, Mirantis, Rackspace, those type of players. And you want to provide them with pre-notification about the upcoming security fix using pre-release versions of your security advisory along with the source code and patches you've developed. So this is called your embargo period. So someone just found a vulnerability, you think you have a fix, ideally you've come up with this in 3 to 5 days, and you've contacted your distributors to say, hey, look, this is what we're planning to roll out, here's the impact, so you can get your patches and stuff ready so you can have your product push out those updates. That's not a long time. That's actually pretty aggressive, 3 to 5 days. Now, after that 3 to 5 days, this period over is normally when they'll open up bug reports for the security vulnerability. So a lot of them were hidden or out of the community space for that time. So the vulnerability management team can choose to open bug reports sooner. They'll do this if the fix takes usually more than 2 weeks. So if they're looking at this fix and they're, well, either, okay, it's very complex and we require multiple stakeholders to make this fix, or it's actually really large and it's going to take a time to get this fixed, then they'll open the bug report and push that out to the community sooner, giving people the ability to try and mitigate on that on their own. So how do you get patches? It's up to your OpenStack distribution to provide you with those updates. Like I said, you should review their workflow prior to using any of their products or purchasing OpenStack products. It's really dependent on that. So network security. So inside the OpenStack space, there are considered 4 security domains. There's the public, guest, management, data, and storage. So these security domains can be mapped independently or combined to represent the majority of the possible use cases around the trust areas in an OpenStack deployment. For example, depending on your deployment guidelines, you may decide to merge in or combine the management and storage network, or maybe you combine guest and data storage. It kind of depends on what your overall technology choices are. And it also depends whether you're building a private, public, or hybrid cloud. So the public domain, so this domain should obviously always be considered untrusted, as it is your external users or people coming to you on the internet. You should normally never trust anything coming in on this space. The guest domain. This one is kind of up in the air. So this is your instance-to-instance traffic. So if you have 10 compute nodes with 100 instances on there, this is the network domain where all of these instances will talk to one another on inside their project space. Personally, I would consider this domain to be untrusted and always untrusted. Now, they talk here about, well, if you have control over images and if you have control over certain parts, sure, you can consider things trusted. But I'm pretty sure like once your OpenStack environment is up and running, someone's going to come to you and they're going to want to deploy what they classify as, I want a DMZ project in my cloud space, right? That's easy. A couple clicks should be done. Or I get the, we're doing a joint venture opportunity with another company. Can we just make something in the cloud space? It's secure. Beta environments for our products. We want a new beta environment so our customers can come in and access this. Yeah, my favorite one is, hey, can we make another QA environment and make it external to our customers? Yeah, that sounds like a great idea. So as these people come with these requests, right, you need to make sure you start off that, okay, down the road, is this domain going to be trusted or not trusted? I would personally always leave it as an untrusted space. Next is your management domain. So inside your OpenStack environment, you have the external endpoints, you have all your internal API services. On this is also AMQP, which is usually RabbitMQ or something like that. You have your backend database. This domain is normally considered a trusted place inside the OpenStack environment, which means it all should be considered highly secure and highly monitored. No one should have access to this. Even if you're doing a private cloud inside your company, the subnet or the network, physical network this is on should not be accessible to your end users. Because what will probably happen is that one of them will stumble across these API endpoints either by accident due to a configuration issue or just exploring, and they'll end up writing a whole bunch of software through it, and then eventually you'll find out that a lot of people are using your management network when they should be using your public-facing APIs. Data domain. This one is totally up in the air. So it is where all of your storage traffic will go over, but it is highly dependent on what technology you've picked under the hood. For example, if you're using an iSCSI network, you probably want that separate. If you have fabric switches, maybe using a SolFire with the NetApp, it all really depends on what your underlying technology is. So this one is really up to your deployment decisions. What technology you've used under the hood for all of your block storage in your Cinder deployment. So back to this lovely diagram. So we look at the space. Now when you think about this, you're like, well, all right, so I have all my public stuff coming in on the black lines, arrows into my environment, making all those API calls. That should be separate, that on the network somehow isolated. I have all my internal API calls to all my load balancers and all my controller services in the red. That should be separate and protected. And then I have all my instance traffic in there where all my VMs are talking to one another. That should be separate. And I haven't even discussed storage yet. Which begs the question of how many network interfaces should I put in my cloud boxes? So to recap, on the security domains, on the outside you have that Horizon HTTP interface with all of those OpenStack APIs. And on the management, you have the same Horizon interface, OpenStack APIs, with the additional AMQP interface and the database interface. And then when we talk about OpenStack APIs, it is all of them. Keystone, Nova for compute, Cinder for storage, Image or Glance for images, Neutron for networking. And that also is any other supporting services you chose to install inside your cloud environment. So if we look at this picture here, right, we have our green and black lines have represented our public domain incoming in. The blue in the middle is all of our guest traffic, and all these instances will communicate with each other and the Neutron processes. One thing to keep in mind here is that each project has their own software-defined network inside this lovely blue line here, which could be VLAN, it could be VXLAN, or it could be GRE tunnels. It really depends on on how you've deployed it. So you can have multiple overlays going on in that space. And then at the top there, your red line is your management network. So based on this diagram, if this was the layout you chose for your cloud environment, and assuming you have bonded interfaces because you want to protect against failure and redundancy, your compute nodes are looking at 4 interfaces. Your controller nodes are also looking at 4 interfaces. and your network nodes are looking at 6 interfaces. And then we haven't even talked about storage at all. So if you're trying to plug in an iSCSI network to something in here, well, you're going to have to add interfaces for storage as well at this point. So here, here's, yeah.
When you, on the previous one, when you talked about nodes there, are you talking about physical servers or these VMs?
Physical servers.
All of those are physical servers?
All those are physical servers.
All right.
Yeah, it gets to be a lot, especially depend on your size and what your sometimes your network requirements are. So, for example, in this picture, your network node is off to the side, and it's different than your controller node. Depending on your product, you can combine those together. So, for example, let's say you have 3 controller nodes. Well, they can handle all the controlling services. But then you run into the issues is, okay, I have, what's it like, 20-something controlling services, and then what is happening inside your cloud environment? Let's, for example, if you're doing a lot of network bandwidth in and out of the cloud environment, you might have to move your network nodes off to the side to like isolated boxes, depending on what kind of throughput you want on there, right? Because you may not want to share those resources with somebody else. Yeah, so it can end up being a lot. It can end up being a lot of physical interfaces, but it all depends on like, are you going like really cheap commodity and you're not going to bond any interfaces at all? Or, are you comfortable combining some of those security domains together? Or not combining, but let's say you have one set of bond interfaces, you can get away with running each of these security domains on their own VLAN under the hood. So even though you have one set of interfaces, you're still separating them at the VLAN layer underneath. No worries. So here's an example of a compute node. So this is from the OpenStack deployment guide, the OSAD project. So inside the OpenStack space, their rack space, I think it's probably about 2 years ago now, released their deployment tools as like an open source product. It's called OSAD. You can look it up. It's it uses Ansible under the hood for all of its deployment gear, or I guess it's configuration management. So this is from their diagram. So here their compute node. Example has 4 interfaces, bond 1 and bond 0. The public access to your instances will come in on the blue links, which by default the Rackspace tools use VXLAN for all their communication. So we'll come in on there. Does everyone know what VXLAN is? I'll give an update on VXLAN. So on the red side, this is where your management and storage traffic come in. So they've combined it on that. They've separated out that physical interface. And then, yeah, tenant traffic's on the blue one. So inside the OpenStack space, when you deploy networks with software-defined networking, you kind of have 4 options. You have the flat network, which is mean you've just given the raw interface to a tenant. The problem with that is only one tenant can use that interface at a time. The second option is VLANs. So let's assume your organization is really good at VLAN management, and you carve off a block of free VLANs, somewhere maybe to 1,000 to 2,000. You put that in your OpenStack config. Every time someone builds a network in there for a tenant, OpenStack will pick one of those VLANs, IDs that's free, and we'll use that for all of the networking functions inside that project or tenant. That works out fairly well for small organizations. The issue that I find people run into is either they're building a cloud that's a lot larger than they anticipate, so they end up running out of VLAN IDs, or their organization was not set up to carve out blocks of VLANs, IDs like that, and give it to an OpenStack space. They've used VLANs, through multiple offices. Maybe they've inherited companies over the years, so their VLAN ID range is really not sequential. You can use GRE. GRE was really good in the past inside the OpenStack space. However, that has its own limitations, either overhead, the way the encapsulation works, that sort of stuff. So the current favorite one, depending on what you're doing, is VXLAN. So VXLAN gives you a layer 2 overlay on top of a layer 3 network. So what that means is most networks are layer 3. You have an IP address, you talk to people in your subnet, and then you hit a router or a gateway, and then you get out onto the internet wherever you want. What VXLAN does is it takes all of your tenant traffic, and it gives you a layer 2 over top of that. So The VMs can communicate with each other. The VMs can communicate with the router that has an interface on their subnet. And VXLAN will take their packets, encapsulate it in UDP, and send that to the correct point where it needs to go. So that keeps it that's on the tenant side. And then when it hits your neutron router and goes to leave that space, then it's hitting some more physical network that the provider of the OpenStack layer has set up. Everyone good on layer 2? How layer 2 works? All right, I won't cover that. So, back on the SATA tools. So the diagram on the left is what a controller node looks like, and the diagram on the right, I just blew up that middle spot, so hopefully it's easier to see. Yeah, there's a lot going on in there. So the OSAT tools that are from Rackspace, what they do is on one hand, it's really good because they allow you to put your controller services wherever you want on any machine. The bad part is everything they do in a container. So it's great because if you have an issue with a container or you want to try a software update, everything is isolated. So like if you want to try a new version of Keystone, you don't have to worry about mucking any other controlling services. There's about 20 of them on there. So you can blow them away, recreate them, move them around. It's awesome. But everything's in a container, which gives you another layer of abstraction at the network layer. So not only do you have to be able to handle the Neutron Linux bridging support that happens in that space with VXLAN, then you also have to contend with how do my containers get access to all those raw interfaces underneath the hood. Yeah, it's pretty good. But same thing, right? Everything on the red, that's where your management and storage domain traffic leaves. Everything blue on the right is all of your tenant traffic, right? So for example, if you had a tenant coming in and he needed to get DHCP and hit his router, he would come in on the blue side over VXLAN, and then it would get passed out to the other places. Now, if you follow the OSAT tools, when you do this, you'll see here that they have a BR management, a BR storage, BR LAN, and a BR VXLAN interface and bridge. So they also break everything up into Linux bridges, which is great because then you can pass those Linux bridges up into the OpenStack services, but you have to be comfortable with Linux bridges if you're going down this path. One other thing to note. So earlier when we talked about the security domains, we talked about the management domain and how that domain should be highly secure, not accessible from anywhere else. The Rackspace tools out of the box don't add any routes or default gateways inside the management subnet that they deploy. So when you deploy the Rackspace services across your fleet of gear, it works out really well, except nothing can talk to the management network, and the management network cannot talk anywhere else. It's just something to keep in mind. So on the good side, it's very secure. On the bad side, you can't get to it unless you're on that layer 2 network, which, depending on your organization, could be annoying. So network interface setup. So here's an example of setting up a controller node. So on the left-hand side there, we're just going to bring up a management VLAN sub-interface on VON 0. And on the right side, we will set up a management bridge, add that sub-interface to it, and then we can pass that off to all of our containers or all of our new OpenStack controller services. And you'd have to repeat this process for the BR storage, BR VXLAN, and the BR VLAN interfaces if you went down that path. So here's a picture of the Neutron agent. So this one here has set up for both. It will support VLAN and VXLAN. This might be hard to see from the back. So on the left side, that's showing the path for VXLAN packets coming in and leaving. And on the right side, it's showing the path for VLAN packets coming in and leaving. That sub-interface we created earlier, you would attach it to the BR VXLAN interface or bridge on the left side, and then these Neutron services, they end up creating a tap to this bridge and then pulling it into the VXLAN bridge inside there, and then from there they'll have another tap that goes to their namespace where they do all their networking activities. So inside when Neutron starts up, all of the software-defined networks all of your tenants created, a lot of times will have routers, DHCP agents, all that type of stuff. All that is handled inside their own network namespace, so they're all isolated from everything else. SSL and TLS configuration. So now that we have all of these controller services and APIs up everywhere, and assuming we have some kind of security domain separating the outside from the inside ones, by default, a lot of these services are just standard HTTP. So it means usernames, passwords, config data, tokens, all type of stuff is sent across unencrypted. Here is a list of the endpoints that exist, I would say, on a standard OpenStack environment, assuming you've added in no supporting services that you would have to somehow protect, ideally behind SSL. So the OpenStack security guide, which is on that link that was on the first slide, actually has some really good information on what type of SSL settings you should need, algorithms should be in place, how to lock down, for example, RabbitMQ, or how to lock down access to the database. By default, a lot of the database backends in OpenStack is MySQL Galera. So it's got documentation on how you can lock that down with SSL. However, there are some gotchas when trying to implement SSL and TLS. The first one is they actually recommend using an SSL or TLS proxy in front of the OpenStack services. This diagram here, the OpenStack API endpoint service, whatever it is configured to run on the loopback interface only. And the SSL TLS proxy is actually in front handling all of your SSL TLS communication. There's a few reasons for that. One is that there could be scaling or performance issues with handling SSL inside the OpenStack service. So a bunch of them are written in Python. Depending on what libraries are used under the hood, SSL encryption and decryption is not always the fastest inside the Python space. So it really depends on how big your cloud environment is and what you're doing with it, whether or not that'll be a concern. The other one is they're upfront about those API endpoints not being fully scrutinized yet or well tested in the wild, where when you get things like HA proxy or other tools out there that offer SSL and TLS, they've been around a lot longer and they've proven themselves in that space.
So you would put a third-party reverse proxy there?
Yeah, you can. You can. If you use the Rackspace tools, they give you an option to use HA proxy kind of out of the box. There's a bunch out there that can integrate with F5s. There's a bunch of different options out there. And then it also depends on your organization, right? Like, are you comfortable securing access to the API at the load balancer, which is everyone coming into you? Maybe you for some reason don't need to secure your internal management API requests. Or maybe just terminating all of them at the load balancer is great, because it doesn't matter where your client is, he's terminated. However, from the load balancer to the service, that's unencrypted. And that could be okay, but it's kind of on your business needs, right? But if you're trying to guarantee some level of security, then you probably want to have encryption the entire way. One of the things you can do is that you can encrypt from the clients to your load balancer using SSL TLS, and then you can easily turn on encryption inside Keystone, which is your authentication service. So you would encrypt all the usernames and passwords that go throughout the system that are set up everywhere. However, you would not encrypt further API calls where a token is passed around. So the initial setup is great. Later on, when they're making subsequent API calls, that token is not encrypted. So it's a trade-off. It kind of really depends on what you're going for with that OpenStack environment. So here's an example where, using HA proxy to load balance those API services. They have a CA sign certificate, something that people trust that shows up in the browser, and they're very happy with it. And then again, at the back end, maybe they're using a self-signed cert or something in the organization that's a little easier to manage. So if you go to the site, they have a very detailed security guide covering everything around network security to hardening nodes, to using AppArmor or SE Linux with KVM to help protect those instances. There's tons of different stuff out there. Now, I do have an OpenStack environment up and running that I can show you before we run out of time. Does anyone have any questions? No? Good. Does anyone want to take a guess at how many different passwords you could have to create inside an OpenStack environment? Nobody?
4 for each of the one?
Right now in my environment, there's 54. Yeah.
Take it through all the same way down like that?
No. Okay, we'll just wait for this. There we go. Oh. Oh, I'm in full screen. Exit. There we go. So, I do most of my work inside Parallels because half the stuff I do is on Ubuntu, and well, I like keeping my Mac pristine, so it continues to work as is. So inside this VM, I have a complete running OpenStack environment that I'm assuming will make me log in again. Demo. Just to make sure Quinn believes me. Yeah, so there are all the different passwords I have for every service inside the space. They're all different. I can't take credit because they're all randomly generated. I use the OpenStack or Rackspace's OpenStack Ansible deployment tools to build this VM because, well, it allows me to build everything on one VM. It's great for testing. As you can see, here's all the containers that are running on the system. The Galera containers deploy in triplicate. If you deploy this against your fleet of nodes, everything is set up with a minimal of 3 instances. And it also takes care of the load balancer, so it works out pretty good. So here's my OpenStack project. I could go to demo. And all the instances built. If we look at the network, so this network, topology, that exists inside here is a VXLAN network. As you can see, I have a private space, a router. Public is the outside network that I will use to connect to the internet or other places. And I have a DB network here that is currently orphaned because I have not added any router interfaces on it. Now, from the security point of view, if I were to build any instances in here, they would get built onto the private network, which uses VXLAN to terminate to all the nodes. And then because I have a router here, I can get to the internet. Now, one thing I did do that is a little crazy, there's a really good talk on once you have OpenStack running, using OpenStack and the software-defined networking inside there to actually increase the security of your current environment. Because right now, like, it doesn't matter, even with like VMware or NSX, that kind of stuff, fencing projects or fencing joint venture activities or other stuff you do in an organization is hard today, right? Like, because you figure you got firewall rules around the entire project, then how do they integrate with other projects? There's all the stuff you want to put together. So there's a really good talk here. So I was setting up this demo to kind of give it an overview of, so if you have an OpenStack space and you can build all of these networks on demand, well, then you don't have to worry about provisioning or contacting other departments or anything like that. And then every project and every instance has a security group, which is a firewall that you can allow or remove things. So what I've done here is I've created inside my space, I created a web project, and I can give developers access to the web project. So developers can come in and they can build instances in the web project, and that's all they can do. And they can attach it to the web network. I created a DB project, so database people can come in and they can build databases in the database project space and access their database subnet. That's all they can do. They can't do anything else. However, I created an interconnect project that me, as the special admin person, I get access to. Inside here, what I did is I took an interface from the DB Web Connect, which all the web servers are on, and added it to my router. And now it has access to the database nodes. And then I gave another router called Gateway Router access to the internet. So now from this project, I get to control, as developers are rolling out all kinds of crazy applications, which networks actually get to talk to which points. So if you're trying to do a really good job at application segregation inside your space. This is one way that you could go about it, right? I don't have to be concerned now that every time a developer wants to build a new web app, that they're picking the right subnet, or they're talking to the database on the wrong port, or they opened up too many ports, because well, now I have it locked down by these security rules. And we've kind of compartmentalized things, and everyone has their own duties in their own confined space. So there's another really good talk where there's other off-the-shelf products you can buy, or there's ways you can add in network tap devices in here for monitoring. So let's say you have an IDS or a FireEye or some other network intrusion detection system. You can go in here and I'm like, well, okay, well, actually, I think there's something wrong with like this web subnet, right? If I have multiple applications in my web space and they're all in their own network, well, great. I can go in here, I can delete this interface off this router, and I can move that interface to another router. I can move that interface to some kind of black hole zone if I want. I can move it to my forensic network, where all of a sudden everything is either logged or there's more, maybe there's a SIM in there, that kind of stuff. So it kind of gives you control on how to compartmentalize that stuff as you move it around. So that is pretty cool. Does anyone else have any questions? No? All right.
Well, it's just around mix technology. So can you mix ESXi in the backend? Well, I mean, OpenStack would handle all of the VMs. I'm thinking about AWS and your local servers.
Well, some things you can mix. So you can't mix directly AWS with OpenStack components. Since Rackspace has a vested interest in OpenStack, and obviously as a data center seller, they actually do quite a bit of work of trying to make it so you can grow into the cloud and expand back. OpenStack with the Liberty release has multi-domain support, where you can federate out authentication services between different ones. And then inside compute nodes, like right now my compute node is running KVM, you can add in different compute node types. Here, I logged in as admin. So the only caveat there is around when you try and add in ESXi. So VMware does have some, let's say, constraints when you add in ESXi. So I believe I think they require you to use vSphere. I think you require an enterprise license or enterprise plus. I could be wrong, but I think it also might require you to use vSAN. But in theory, you can have an OpenStack environment, you can have some KVM pools, you can have a Hyper-V pool, you could have an ESXi pool, and you can mix and match. And then you can create things like availability zones or host aggregates where you can carve that up. So right now I have a default one called Nova that's just my box is under, right? But we could create an availability zone or a host aggregate that just matches the ESXi. And then you, on your image tag, you can say, hey, you know what, every time someone builds an instance from my Windows image, force it into that host aggregate. So my Windows images are always inside my ESX because maybe you're using DRS or something like that. You can do the same thing with image sizes. You could say, hey, I have a performance image. So every time someone picks the performance image, the performance flavor, you could say, hey, I want these type images because these are all the ones that are in the default. You can say, hey, every time you pick the performance one, force that one to go to my SSD node. You know, I have a fleet of SSDs inside my space, and you know these cost more, so people get charged more, and I want people to pick those. I don't want anyone to get them at random. So you can do stuff like that to control where workloads go inside your OpenStack space. And then the one other thing that's kind of neat is, so under networks, all the networks that are in there got built as a consumer of the space. So I logged in as my regular user, I went to my project space, and I said, build me this network. You know, it asked me, what's my subnet, give me a name. That's kind of it. Underneath the hood, it gets built using VXLAN. If you come in as an admin and you build a network, you can pick maybe VLAN or VXLAN if you had a specific segmentation ID. But here, let's assume you built this huge cloud space inside your corporate network. And you want to make it so my developers have one project space that's actually tied to my corporate LAN, so they don't have to use floating IPs and stuff. You can create like a developer network, and you can give it a specific VLAN ID, so you know if a developer builds something on this network, it can be shared out, it can be accessed from different places. So you can do stuff like that underneath the hood.
Last question, and then we gotta wrap it up.
So I guess, can we add the AWS instance to the OpenStack network? And can we use like OpenStack front-end management to manage all of the instances from a different platform like AWS, like OpenStack?
No. No, you can't. So if you have like AWS space and an OpenStack space, on the network layer, you could have a routed boundary that connects those two together for you underneath the hood. But the management tools are separate at this point. Now, if you took a step back and used a different management tool, like Ansible or Puppet or Chef or something like that, you can have like Ansible manage those two things.
Thanks.
Can we have Michael answer any questions out in the hall? We gotta wrap it up. You with your hand, I feel so sad. We just gotta switch out our room. Thank you, Michael. This feels like the last day of DevCon and you broke my brain. Appreciate that. So, hope you guys enjoyed it. Thank you so much. Thanks for being here.